Welcome back, and in this particular video we will be discussing the problem count occurrences of an integer. We are given a sorted array of length n, which is consisting of integers with possible duplicate elements also. There can be multiple repeating elements also in the array. Find the minimum number of occurrences, or actually not minimum, but the number of occurrences of an integer k using binary search. It is specifically mentioned that we have to find the number of occurrences of a given target integer using binary search only. So there can be certain test cases assigned to us. Let's read the input format to understand it clearly. There are two lines of input. First line contains two space separated integers n and k, the number of elements and the integer k, that is the target. So second line will be consisting the n space separated integers, all the array elements. Output format will be counting the number of occurrences of the integer k. So maybe you are somewhat familiar with the problem statement. Let's actually understand it using a sample test case so that we can get a clearer idea. If let's say there are 5 elements in the array, n is 5. If there is k is equals to 2, that is target value is 2, we need to search for 2. In this array containing -1, 2, 2, 4, 7, how many occurrences of 2 are there? There are 2 occurrences of 2 present. So output will be 2 because the target integer 2 occurs 2 times in the array. So what will be the constraints associated with this problem? Constraints will be that minimum n will be 1, that is n is greater than equal to 1. At least array will contain 1 element, and maximum the array can contain 10 raised to power 6 elements. And the target integer can be anything from negative to positive. Similarly, the array integers will be anything from negative to positive. That is, array can contain any value in a integer range. So let's actually understand this problem statement using some more test cases and what all corner cases there might be regarding this problem. So in the first input, it was a pretty standard input, but what do you think will happen if, let's say, I am having only one integer in the array? Let's say n is 1 and I am saying k is a 10. And if the array is containing only one element, it can be 10. It can be anything other than 10. So if it is 10, how many occurrences of 10 are there? Only one occurrence of 10 are there. If let's say the array is containing anything other than 10, maybe 20, and target was 10, then how many occurrences of 20 are there? There are 0 occurrences of 10 in the array containing only 20. So there can be a corner case where there might be only one occurrence of target, or there might be no occurrences of target also possible. So this is a second example, or you can say the most basic example, a corner case. And there might be obviously a array containing multiple elements also. So if I am taking an array containing n is equals to 7 elements and k is equals to maybe 30. So if I am taking an array containing maybe, let's say, 10, then let's say there is 20, let's say there is another 20, let's say there is 30, 30, 30, and let's say there is 40. So if this is the array, and this array is containing how many elements? 7 elements. I have taken a random example from my own. Target is 30. How many occurrences of 30 are there? There are 3 occurrences of 30. So what will be the answer? Count of occurrences will be 3. So we have to count the target's occurrences in a sorted array. It is given in the question itself. So what is the first approach which we can think of? Till now, we have done the first milestone, that is understanding the problem. Now we are jumping on towards the types of approaches which we can use. Obviously, the problem is saying that we can do it using binary search itself, but a brute force solution for this problem can be just do a simple linear search. So if I just say the approach number 1 is a simple linear search, how we can implement a linear search in an array containing duplicate elements or repeated elements? If let's say the array is containing 10, 20, 20, 30, 30, 30, 40, and if we are searching for the target 30, that how many target elements which are equal to 30 are present in the array. What we need to do is, we need to run a simple iteration, a simple linear traversal. So we will maintain a count variable initially to 0, and we will check, is the current array element, is it equal to the target, that is k value 30? No. Is it equal to 30? Is it equal to 30? Is it equal to 30? Yes. So count plus plus. Is it equal to 30? Yes. Count plus plus. Is it equal to 30? Yes. Count plus plus. As soon as you go to a target, the current element which is greater than target, you can say now break out from the loop. So there are 3 elements in the given array which are equal to the target. So we can return the target very easily. So this is the first approach. How much will be the time complexity? How much will be the space complexity? Time complexity, since we are doing a linear traversal, will be order of n, linear. And what will be the space? Are we going to take any extra space? Actually, no extra space will be required. So constant extra space in place solution will be there. But are we able to do anything better than linear search? See, if there is a ordering, if the array is monotonically increasing, that is all the elements are in ascending order, can we apply binary search? Can we div divide and conquer? Can we apply the logic of whether we can go in the left hand side or in the right hand side based on some conditions? So that we have to figure out. So if I, let's say, add a page and then take a same example and try to apply a divide and conquer strategy, that is try to implement binary search in this particular array, what will happen? Let's see. So if I'm having this array containing all these values, so let's say this is 0th index, first index, second index, third index, fourth, fifth, sixth. So all these are the indices present. And what we need to do, let's say, actually, to make the problem a little bit more interesting, I am adding one more element, and that element I am saying is a 20. I am adding one more value which is 20 in between to make the problem a little more interesting. Okay. Anyways, so if this is the array, what we are trying to do, we are trying to implement binary search. That is, we are trying to reduce our search space by almost half every time. So initially, what will be the search space if I say you? Initially, the search space will be the entire array. That is, all the occurrences of target can be present in any of the array elements. So initially, left pointer will be 0. Initially, right pointer will be array.length. I will ask to the mid element, that is whether it is equal to the target, if it is lesser than target, if it is greater than target. Only these 3 conditions are usually there. So what will be the middle? Middle will be 0 plus 7 by 2, that is third index. I will ask to the middle value whether it is equal to target. What was target in this case? Target we were taking was 30. Since 20 is lesser than 30, can we say that all the occurrences of 30 will be in the right side of 20 only? Since the array is sorted in increasing order, all the occurrences of 30 will be in the right side of 20 only, because 20 is less than 30. So can we discard all the elements from left till mid? Yes, surely we can. And if we can discard, what we will do? We will do left is equals to mid plus 1 by discarding the range left till mid. We will figure out the new mid. What will be the new mid? Left plus right by 2. 4 plus 7 by 2. The mid will come out to be fifth index. Now see very carefully. Now if I am asking to the mid value, is it equal to target? Is it greater than target, or is it less than target? If it would have been greater than target, then obviously you should know that we will be discarding the right range. But currently the mid value is actually equal to the target. And what we need to do in this question? We need to count the number of occurrences. So how we can actually count the number of occurrences if we are at 30? One way you can expand in the left, expand in the right, but that will be linear search only. If you are just expanding one by one in the left, one by one in the right. What actually do you need to do instead of expanding one by one? Can we say that if the array is sorted, all the elements which are equal to the target, or be that matter any element will be having all of its occurrences together adjacent? Yes. If a array is sorted, all the occurrences will be adjacent. So can I use this property that all the occurrences will be adjacent? Yes, surely we can. That is, if I am saying all the occurrences of 30 will be from 4th index till 6th index, if somehow I am able to get the first occurrence of the target, similarly, if somehow I am able to get the last occurrence of the target, can I say that all the occurrences will be in this range, first occurrence till last occurrence? So how many elements will be there which is equal to target if I know this range? The number of elements will be last occurrence minus first occurrence. Will it be the formula? Will it be 6 minus 4? No, it will be 6 minus 4 is equal to 2. No, there are 3 occurrences, not 2. So we have to do first, last minus first plus 1 actually. Example can be, if I say to you, if I ask you a simple question that we need to count numbers from 1 to 10, including 1 and 10. how many numbers are there? If you will say 10 minus 1, 9 numbers are there, you are wrong. Obviously, there are 10 numbers. If you do a simple counting from 1 to 10, there are 10 numbers. So what is the formula? Formula is 10 minus 1 plus 1, right minus left plus 1. So here also, since we need to count the number of occurrences from left to right, including from first occurrence to last occurrence, including both the occurrences, we need the formula last occurrence minus first occurrence plus 1. So given the mid value, we are at 30. What we will say? We need to search the first occurrence. We need to search the last occurrence. So where will be the first occurrence? Obviously, first occurrence will be in the left hand side. Where will be the last occurrence? Obviously, if there is a last occurrence, it will be in the right hand side if the target occurs. So we have to now go in the first occurrence for the left hand side separately and for the right hand side due to the last occurrence separately. That is, we have to implement two different functions. One function which will search the first occurrence of a target element, another function which will search for the last occurrence of the given target. So if I basically do a dry run firstly for the first occurrence, let's see what will happen. So if I take the again the same array, that is 10 20 20 20 30 30 30, and let's say there is 40. So currently, where is left? Left is at fourth index. Where is right? Right is at seventh index. And we will figure out the mid. Mid will come out to be fourth index plus seventh index by 2, that is fifth index. Since it is equal to target, what we will say? Where is the first occurrence? It might be in the left hand side. So we will make right is equals to mid minus 1. We will figure out the new mid. New mid will come out to be left plus right by 2. This is how we do it. Now, as soon as we ask to the mid element, it is also equal to target. In order to search the first occurrence, we will again try to go to the left hand side. We will become more greedy. That is, we can say that there is a potential answer at the current index, but there might be more occurrences of 30 in the left, because first occurrence will be the leftmost occurrence. And as soon as I go in the left side, that is make the right is equals to mid minus 1, the left and right pointer crosses each other. That is, the entire search space is discarded. First we discarded 10 20 20 20, then we discarded this range, and finally I am able to discard the last element. So I have discarded the entire array. So finally I should stop. Why? Because left and right are cross each other. Left is more than right. And what is the target occurrence first element, first index? The target element's first index is nothing but being pointed by the left pointer. So left pointer is the pointer in the first iteration to find the first occurrence. Similarly, I will do the iteration for the last occurrence. That is the rightmost occurrence. So let me just create the array again. 10, 20, 20, 20. Then there is 30, 30, 30, 40. If this is the array, initially where was left? Initially left was at 0, right was at 7. We basically tried to figure out the mid came out to be 20. Then we got to the right side. So I'm skipping all of that part. I'm directly making the left as the fourth index, right as the seventh index. Mid will come out to be the fifth index. We will ask to the mid value. Originally, we are saying that this array is been discarded. So we will ask to the mid value, where is the target's last occurrence? If it is equal to target, last occurrence will be in the right side. So let's go into the right side. That is, discard the left region by making left is equals to mid plus 1. We will figure out new mid, which is 6 plus 7 by 2. That is 6 only. It is also equal to 30. But as soon as I will go to the right side, I will make left is equals to mid plus 1. I will ask to the new mid. New mid will come out to be 7 plus 7 by 2. That is 7 only. 40. It is greater than 30. If a 40 is greater than 30, what should we do? We should go in the left hand side, because we are greater than target. Target will be in the left only. So as soon as I go in the left hand side, right will become mid minus 1. And if right is becoming mid minus 1, the entire array is done. We are remaining with no element in the search space. Search space is empty now. So where is the target's last occurrence? Target's last occurrence is being pointed by the right pointer in this case. Previously, for the first occurrence code, it was being pointed by the left pointer, but now it is being pointed by the right pointer. It is just due to the dry run we are observing the pattern that in the first occurrence, while we are doing the binary search, after the binary search is complete, that is after the search space is empty, we are getting the answer at left. And similarly, after the binary search is complete in the last occurrence code, we are getting the answer at right pointer. Once we know where is the first occurrence, fourth index. Once we know where is the last occurrence at sixth index, how many occurrences will be there? Total number of occurrences will be 6 minus 4 plus 1. That is last occurrence minus first occurrence plus 1. So last occurrence was 6, first occurrence was 4, plus 1 will be 3. So 6 minus 4 plus 1, that is 3 occurrences of target are there. This was the dry run which we done for the binary search code. And with that, we have basically done with the finalizing of the approach, that is using the binary search logic. And we also saw that how actually binary search is working and why it is working, because we are able to apply the divide and conquer. Now, what is the time complexity if we are going to do binary search? Since we are applying binary search two times, one time for the first occurrence, one time for the last occurrence, total time complexity will be 2 times log n. One time log n for first occurrence, another time logarithmic for last occurrence. So overall time complexity will be 2 times logarithmic. And what will be the space complexity? Since we are not going to take any extra space in the iterative solution, the space complexity will be constant. So you can actually implement binary search using any of the approaches. You can implement it using iteration, that is a normal for loop or while loop, or you can also implement it using recursion if you know recursion. But better will be to do it using iteration. Why? Because in iteration, time complexity is logarithmic, actually 2 times logarithmic, but we generally ignore the constants, and space is constant. While in recursion, time will be still logarithmic, but space will be logarithmic also. The space complexity will also go logarithmic due to the recursion call stack space. Because of this overhead, we generally ignore or we generally avoid the recursion code in terms of binary search. You can do it as your practice, but I will be doing the code using iteration only. So now that we have done with the second milestone, we will be coming up with an instruction manual for this problem. And whatever loopholes will remain, we will be covering them in the expansion video, the code expansion video. Nevertheless, so in this code, we are given an integer n that is representing the array size, integer k representing the target element, and a array represented by a array of integers a. What we need, first of all, we need the first occurrence. So better will be to call a function first occurrence to get me the first index. So get the first index from a function call. Get the first index from a function call. Similarly, I will do what? I will get the last index from a function call for the target. First index of target. Similarly, last index of target from a function call. We will have to make two different functions call. One for the first index, one for the last index. As soon as we get both the indices, we will say what? A corner case might be there. We will say that if there is only one element or if there is no elements of target, no occurrences of target, we will handle that, handle no occurrences of target. We will see that what we have to do in this case. But apart from that, what is the answer? The answer is number of occurrences is the first, actually the last index minus the first index plus 1. So we will say calculate the count and return it. Calculate, count and return it, and return the value if it is not a corner case. And corner case might be handle no occurrences or single occurrences. Single occurrences or no occurrences might be handled separately. So now what we need to do, we need to implement two functions, that is the first occurrence and actually the last occurrence, first index and the last index. Both will be returning integer. Why? Because both are expecting a index only. So index is integers. So I will pass the array. I will pass what? I will pass the target value, that is k, and that's it. Similarly, for the last index function, I will pass the array as well as I will pass the target, which is k. Once we have both these integers, both these functions with us, what is the pseudocode for the first index? We will say initialize 2 pointers. Initialize 2 pointers, which are there. You can say them that they are low and high. You can say they are left and right. You can say anything. I generally use left and right nomenclature. And initially, what will be it? 0 and nums dot length. Array last index. Arrays last index, respectively. Once we have both these pointers initialized, we will apply the binary search. Till which point? While the binary search will be applied till there is some search phrase, that is while left is less than right. or actually equal to right, less or equal to right pointer, we will apply the binary search. What we have to do inside the logic of the iteration of the loop, we have to calculate mid first of all. So calculate mid as what? As you can use any formula. You can use left plus right by 2, or you can also use left plus right minus left by 2 to avoid the overflow. So for now, we will not have any overflow conditions in this particular question because array is of almost 10 to the power 6 length. So no overflow from integer will happen. So we can use normal formula, that is mid as left plus right by 2 only. Once we calculate mid, what we will say? We will say whether the mid is less than target, equal to target, or greater than target. If array of mid is equal to target, or actually it is greater than target or less than target. Else if it is greater than target, or lastly if it is obviously less than target. What we have to do for the first index, if we were at the element 20, target was 30, where will be the first occurrence of 30? In the right side only. And similarly, what will happen if we are for the coding for the last occurrence? Still at 20, we have to go in the right side. So whether the target is greater than the array of mid, that is array of mid is actually, you can say, lesser than the target. If array of mid is lesser than target, then what we have to do? We have to make left is equals to mid plus 1. That is, we have to go to the right side. So update, we have to do what? Update left as a mid plus 1 in this case. Otherwise, if target is actually smaller, then what we have to do? If let's say we are standing at 40, if the array of mid is 40, what we did? We binary search in the left hand side, that is right is equals to mid minus 1. So update right as mid minus 1. Now the only difference will be when the array of mid is equal to target. So first of all, I will be saying what? In the both the functions, this part is common. Like at least this part will be common. The binary search is common only. Only the thing will be what we have to return in the first index function and what we have to return in the last index function. So while we did the dry run, what we saw that in the case of first index, what we have to return? We have to, I guess, return the left pointer, and in the last occurrence, we have to return the right pointer. So let's return left pointer in the first occurrence function, and similarly, let's return the right pointer in the last occurrence function. Only thing remaining is how we have to calculate that, how we have to update actually when array of mid is equal to target. In the case of first occurrence, when we were at 30, when we were standing at 30 and we have to search for 30's first occurrence, we went to left hand side, that is right is equals to mid minus 1. But when we are doing for last occurrence, we search for the right hand side, that is left is equals to mid plus 1. So this will be the difference. This will be the second difference. That is, in the first occurrence, it will be update the left as mid plus 1. But in the case of last index, the equal case will be update the right as mid minus 1, because in the first occurrence we have to go in the left hand side, for the last occurrence we have to go in the right hand side. So this will be the difference. So right is equals to, actually I have done it wrong. In the first index we have to go it in the left hand side, that is right as mid minus 1 in this case, and in this case we have to do left as mid plus 1, left as mid plus 1. Last index right most occurrence, first index left most occurrence. Now it is correct. So what might be the corner case? What might be a scenario when there is no elements in the array? If there is no elements in the array, what will happen? I will say that the number of occurrences will be 0, but in that case, what will be the state of first index and last index? Let me actually do a dry run. So if I am saying the array is containing, let's say the corner case we are handling is for no occurrences. Array is containing 10, 20, 20, 30, 30, 30, 40. And if we are searching for the target, let's say target is 25. So let's do a dry run for 25. Initially, for both the functions, whether it is for first occurrence, whether it is for last occurrence, we will have the left initially at 0. We will have the right initially at the array.length minus 1, that is the last index. Mid will come out to be 0 plus 6 by 2, that is the third index. 30 is greater than 25, in both the functions, we will do what? We will go to the left hand side because 25 is smaller than 30. That is, I will discard all the greater elements and update the right as mid minus 1. I will figure out the new mid. New mid will come out to be left plus right by 2. That is 0 plus 2 by 2, which is 1. 20 is what? 20 is smaller than 25. And since 20 is smaller than 25 in both the functions, I will discard the smaller values and I will go to the right hand side. That is, make the left pointer as mid plus 1. As soon as I make the left pointer as mid plus 1, I will figure out the new mid. What will be the new mid? Left plus right by 2 only. That is, mid will come out to be second index. 20 again is smaller than 25. Again, we will go to the right hand side. As soon as I go to the right hand side, the left pointer will become mid plus 1. Left pointer will become mid plus 1. And now we can say the binary search is complete. So right pointer is at second index, left pointer is at third index in both the functions, whether it is first index, whether it is last index. So there is no occurrences of target. How we can check it? If there might have been some occurrences, obviously left should have been less than equal to right by. If left is less than equal to right, then only this formula will be valid, because left should be, actually the last occurrence should be greater than equal to the first occurrence, then only this formula will give me a positive value. If last occurrence will be smaller than the first occurrence, then this formula will be invalid, or you can say it will give me a wrong results. So what we have to do? We have to say, if the left pointer, that is nothing but your first occurrence, left pointer was your first occurrence, and the right pointer, that is nothing but your last occurrence. If first occurrence is more than the last occurrence, then the target is not present. If first occurrence is more than the last occurrence, first pointer is more than last pointer, then no occurrences. That is, we have to return 0 in this case. So this is nothing but the corner case. So if we have to say what? If the first index is more than the last index, then we have to return 0 because there is no occurrences. So now that we have written the pseudocode or the instruction manual, we are done with the milestone 3, fourth milestone, that is converting our instruction manual or using our instruction manual to write the code. So first part was to basically get the first index and the last index. So let's try to code the first index part. Initially, we will make the left pointer and the right pointer to the entire array range, that is 0 and array dot length minus 1. Apart from it, we will say apply the binary search till the point left is less than equal to right. And while doing it, we will say what? We will say that ask to the mid value. So first figure out the mid value, that is left plus right by 2, and use the bracket, otherwise the formula will be invalid. Why? Because you have to do first addition and then divide by 2. If you will miss the bracket, it will do only right by 2 and then add left. After asking the mid value, what we will say? It is about to have 3 scenarios, whether it is equal to target, less than target, or greater than target. So if array of mid is equal to target, that is k value, we will do something else. If it is else if it is array of mid as lesser than target, then we will do something else. And finally, else if it is like none of these, then we will do something else. What we have to do if it is equal to the target, since in the first occurrence function, we have to go into the left hand side, we will make the right as mid minus 1. In the case of array of mid is lesser than target, target will be in the right hand side, that is, we will make the left as mid plus 1. And finally, what is the last scenario? Obviously, last scenario will be array of mid will be greater than target. In that, what we have to do? We have to basically make the update of right as mid minus 1. That is, go in the right and actually left hand side. Why? Because target is smaller than the array of mid. So right is equal to mid minus 1. Finally, in the first index function, we have to return the left pointer. So let's first actually do a dry run of the first index function only. Let's get the first index variable as fi, or you can say first is equals to the first index function, where I will be passing the array, where I will be passing the target k. And let's actually print the first index for now. So system.out.println the first index for the sample test case. And since the function is expecting to return something, we will be returning 0 for now, so that there is no compilation error. If I will run the sample test case, what should be the first index of target 2? The first index of target 2 should be the first index. It is present at the index number 1. So if it is going to give me index number 1, then it is good enough. There is certain errors regarding to illegal start type. So let's see what is happening. So we are having most probably certain issues with regarding to the function name, or there might be some curly brackets missing somewhere. So yeah, this is not square bracket, this should be angular bracket or actually round bracket. Let's run it again. There is certain more issues. Array is A, not ARR. Array is A, not ARR. Let's run it again. So these are like simple manual errors which everyone do, and we have to take care of it. Similarly, for the last index function, we have to return something. So for now, I'm returning -1 so that we are not getting any compilation issues. So first index for the number 2, for the target 2 is the first index only. The first occurrence is at the first index only. So at least the first function is working fine. Let's now do the last index function also. Initially, the left pointer similarly will be at 0. Right pointer similarly will be at array.length -1. We will do the binary search till the point while left is smaller than or equal to right. We will do the binary search. Every time what we will do, we will ask to the mid value whether it is equal to the target or smaller than target or greater than target. So let's figure out the mid. The same thing which we have done in the previous code, left plus right by 2, and we will ask to the mid value whether it is equal to target. If array of mid is equal to k, we will update the left as mid +1 in this case. Why? Because for the last occurrence, we have to go in the right hand side, the rightmost occurrence of target. Remaining two codes will be same. That is else if. The second scenario will be else if array of mid is smaller than target. Array of mid is equal to less than target, which is k value. What we have to do, and again, it is not ARR, it is A. In this case, what we have to do? We have to make the updation as left is equals to mid +1. So if you want, you can combine both the cases also, but I am giving separate cases so that it is beginner friendly, it is easily readable. And finally, for the last case, we have to make right as mid -1, same as the previous code. Finally, we have to return in this case the right pointer, which we have done in the dry run also. So now that we have the last occurrence also, that is the last index, let's call the function last and get the answer from the last index function where I will pass the array and the k value. So if I print the last index also, we can be sure whether we are getting it correctly or not. So if I run it for this particular test case, same test case, sample test case, what will be the last occurrence? It should be the second index most probably, and it is giving me second index. So this is also working fine. Now that I have both the functions perfectly fine, what is the answer? How many occurrences are there? Last occurrence minus first occurrence +1. So last minus first +1. Although there is one corner case. So what will be the corner case? Now that we have basically done the basic, all the cases correct, if I run it for the sample test case, it usually should be most probably correct solution. Why? Because second index minus first index +1 will give me 2 occurrences only. But what about a target which is not present at all? If I give the same array, 5 elements, target is, let's say, instead of 2, in the array containing 5 elements, if let's say I am giving a target as 3, and the array is -1, 2, 2, 4, 7. Is 3 present? No, 3 is not present. What we will get if I run the same code without any corner case? So it should give me 0, and it is giving me 0. But you should handle separately. Even if it is working fine, I think we should handle separately. That is, if first occurrence is more than the last occurrence, then there is no occurrences. And if it is no occurrences, return 0. Even if you are not writing it, it is still working fine. But better will be to specifically mention the corner cases even in an interview also. So that interviewer is also clear that we are thinking in terms of all the test cases, all the corner cases possible. Now, if we submit the code, most probably all the test cases should work fine, and we are getting all the test cases correct. So with that, we have also done the 5th milestone, that is doing the dry run for multiple test cases. And as discussed, the time complexity will be logarithmic. The space complexity will be how much? The space complexity will be constant because we are doing the iterative way. So if we are doing iterative way, it will be constant. If you have to do it, if you want to do it using recursive way, the space complexity will also go logarithmic. So let me just bring both the codes. For now, we are having the first index code, that is nothing but a binary search code only. Let me bring it again. So this is the binary search code. Anyways, like it is not like getting loaded, but you can see the first index code. You can take a screenshot if you want. Your all the codes will also be visible in the solution tab. Similarly for the last index, similar code, and finally for the count occurrences.